try part B or?
What was it, Damon? Did you guys have?
Either one.
Yeah, we can do part B.
You sure?
Yeah, because
Okay.
it's on our test.
Yeah.
Alright, cool. So then it says, so how far will a point on the edge of the centrifuge travel in this time?
Okay. So if we've got a particle or something at the very, very tip of our test tube, which is in our centrifuge, we want to know how much distance it's traveled in that 1.2 seconds.
So basically what's theta?
Yeah, so what's change in theta? So it's going to start here, but I'm sorry, what do they ask for exactly?
How far will a point on the edge travel? And then 1.2 seconds.
Yeah, so it's kind of, I don't know if they want the answer in theta, like in radians, or if they want it like in meters. So like, for example, if it started here and it went around, 10 times or something, and then it wanted us to like unravel that 10 times and just lay it out flat. Because you can express it in both ways. You can say, well, it went through, 28 radians, or you can say it traveled 30 meters or whatever.
Oh, it looks like the answer was in revolutions. Revolutions.
The answer is in revolutions.
Yeah.
So that's pretty much the same thing as giving the answer in radians, just different units.
Okay.
So it's saying how far circularly it traveled, rather than laying it out flat and saying how far linearly it would have traveled. So let's go ahead and do that. Let's erase all this. So we're looking for an equation that uses theta. Any preference on what we use or anything coming to mind?
Well, I already kind of know what it is. But
Oh, do you?
yeah.
So I would say,
Theta final equals theta naught.
yeah, well, there's two that we can use. Theta equals theta naught plus omega naught t plus 1/2 alpha t squared. The other option is omega squared equals omega naught squared plus 2a change in theta.
Oh, wait a second. It's actually the answer's in meters, but I did the math right, but my units come out to be revolutions times meters. Does that make sense?
Revolutions times meters.
Yeah.
Mhm. So if you solve for theta using this, you're going to get your answer in radians. And then if you want to go from radians to meters, it's really easy. All you have to do is multiply it by your radius. So
Okay.
if they want the answer in meters, let's go ahead and do that. So I would say this one probably looks a little bit easier to me, but you can totally use this one as well, because we know t, we know alpha, we know omega naught.
So why would you use the second one if it's asking for, like, the time, or the time? Like, I mean, it's not asking for the time, but it's saying how far does it travel in this time when that one doesn't have time?
Because this one, time is actually in there, it just isn't represented by like a physical variable. Because if we know what the acceleration is, and we know what the starting and the final speed is, then the equation is smart enough to just
Okay.
time works itself into there.
Okay.
Because yeah, if you have a set acceleration and you're going from this speed to this speed, there's only one time
Oh,
in which
okay.
that could happen. Does that make sense?
Yeah, that
So
does
if
make
you're always
sense.
given the initial and final velocity, you don't need to use the equation with time.
If you know the alpha, it depends.
Alpha as well.
So this one would be like, yeah, it depends on what we're given and what we're looking for. Because the reason that we have both of these equations is that sometimes one works and the other doesn't.
Okay.
In this case, both work, which
Cool.
happens occasionally. But yeah, maybe let's do this one. So if we subtract this over to this side, what we end up getting is theta final minus theta initial. Another word for that is just change in theta. So sometimes you'll see the equation written like this. This and this are the exact same. So we're looking for change in theta. We know that omega naught was, what was it, like 23 something?
26.2.
26.2 times 1.2 plus 1/2. Alpha was 8 point something.
Yeah, I got 8.75.
Yeah.
8.75, 1.2 squared. This doesn't even require any algebra, it's just everything's on one side of the equation. Oh, I got 8.63.
Yeah, you got like 8.63 or something. I got 8.75 when I did it
I
all.
got that too.
8.75.
So I don't know.
Oh, I must have done it wrong. Oh, wait, no. Yes, that's right. So did you guys get 37.74?
Yeah.
Mhm.
And the units on that is what?
Just rating.
Good, radians. So they don't want the answer in radians though, according to the answer key. So the way that we get from theta into radians is just by remembering anytime we're switching from linear to rotational variables, it's always just, you take the linear one, in this case it's x, divide it by radius, and that gives you the circular one. Or another way that you can write it is the linear one equals the circular one multiplied by the radius. So those equations are exactly the same, just switching r from one side to the other. So if we're looking for x, and we know change in theta is 37.74, and radius was, what was the radius of our circle?
1 meters, I guess, would be 0.06 meters.
Oh, because the diameter is 12 centimeters, so the radius is 6 centimeters, so 0.06 meters, good. So we end up with 2.26 meters. So do you have an answer key, or?
Well, that's what I got, yeah, and that's what the answer key says here too.
Okay, cool.
I'm not sure what I have to.
You did it a different way? Other than this one or this equation?
Yeah, for some reason I converted it to revolutions first and then I
What?
multiplied revolutions times the diameter, that's fine.
Yeah. So you can do that,
And that's-
because, so if we know how many revolutions it did,
Does that make sense?
Yeah.
then all we need to
Yeah.
do is say, okay, well, each revolution is how many meters. Another thing that we call that is circumference, exactly.
That's right, that's right.
So pretty much what you did was you took the number of revolutions times the circumference.
Okay,
So-
so yeah, so I made it 200 revolutions, then I multiplied that. Okay, get there.
Mhm. So there's multiple ways, so you just always wanna be asking yourself if what you're doing makes sense. But yeah, if you find out the number of revolutions, then you find out the circumference, which is the distance of each revolution, and it totally makes sense to multiply those two things together.
Okay.
In our case though, we found out the radians. We know that a 1 radian, the reason it's called a radian is because it's just the length of the radius. So if this is 1 meter, then 1 radian is also 1 meter. And so they have the same length. Radii and radians are always gonna be the same for one circle.
Yeah, 'cause that's what the rating is, that's the arc.
Mm-hmm. So 1 radian is just the degree, or the angle that's necessary to make your arc length the same as your radius length. And so for different circles, obviously that's gonna be different, but that angle is always gonna end up being the exact same angle.
So radians doesn't equal radius, right?
Radians does equal radius. They're different because, I mean, radius is obviously straight, and radian is wrapped around the edge of a circle, but they're always gonna be the same length. if we're looking at the same circle.
Okay.
So if a given circle has a radius of 1 kilometer, then one radian is always gonna have an arc length of 1 kilometer.